All right, we're going to look at some review problems for your upcoming test number 2, which will be on the graphs of trig functions and some of your trig laws. Okay, so one says, given the trig function, negative 1.5 cosine 3x plus 3 pi over 2. So the first thing I want to do is I have to determine if we have the value factored out of the front, which in this case I don't. I got to make sure I factor this 3 out before I start to talk about some of my properties. So if I factor 3 out, I'll get negative 1.5 cosine 3 parentheses something. So then I'll just divide it out. So 3x divided by 3 is just x. And then 3 pi over 2 divided by 3. Again, you could just put a 3 in the bottom because you have 3 pi over 2, put a 3 when I'm dividing. I just get pi over 2. There's nothing at the end, so this would be our factored form. Okay, so again, amplitude is the absolute value of the number in front. So it's the absolute value of 1.5, so it's just 1.5. The graph will be flipped because it is negative, but the amplitude itself is just positive. Period is going to be 2 pi divided by the number in front of the parenthesis, which is 3, so 2 pi over 3. Phase shift is going to be left by pi over 2, because it's that value at the end. And then the vertical shift, there is none, because there's nothing added or subtracting at the end. So just that easy, I have all my properties of this graph. Now I just have to figure out how to get them to be on a grid that is graphed appropriately. Okay? So here is my grid. So again, I'm going to start with my nice values of sine and cosine, 0, pi over 2 pi, 3 pi over 2, and 2 pi. So I would always start by shrinking it to have the appropriate period. So this one currently is 0 to 2 pi, which is a period of 2 pi. So I would first divide all these by 3, because remember, our value is 3. So 0 divided by 3 is 0. Pi over 2 divided by 3 is pi over 6. Again, same reason. When you're dividing by 3, you're putting one on the bottom. This one's pi over 3. This is 3 pi over 2 over 3, which we already did, which is pi over 2. And then 2 pi over 3 is 2 pi over 3. So I'm just dividing them all by 3, or putting a factor of 3 on the bottom. So next I have to do my phase shift. My phase shift, I'm going to be subtracting them all by pi over 2. So this is going to affect the period. So I'm going to divide by 3. If it's a fraction, you might multiply. And this is going to be my phase shift. So when I subtract pi over 2, 0 minus pi over 2 is just negative pi over 2. That's an easy one. Pi over 6 minus pi over 2, we got to do a little bit of work. Pi over 6 minus pi over 2. We have to get common denominators, so we put a 3 and a 3. You could also use one of the yellow calculators to get this value. Pi over 6 minus 3 pi over 6 is negative 2 pi over 6, which is negative pi over 3. So it's literally just adding and subtracting fractions, so that's negative pi over 3. We can keep going. Pi over 3 minus pi over 2 is going to be negative pi over 6. Pi over 2 minus pi over 2 is 0. 2 pi over 3 minus pi over 2 for the last one. We'll write that one down. 2 pi over 3 minus pi over 2. Common denominator would be 6. So a 2 here, a 2 here, a 3 here, a 3 here. So 4 minus 3 is 1. Pi over 6. Again, don't be fiddle with these. Just use the fractions. If you're using the yellow calculator, you can put the pi in. If not, just use the regular function like 1/6 minus 1/2 and then just add a pi at the end, and you can certainly do that as well. So these are now my values that I will segment my axis with. Okay. So let's see if I have all these on here. So I see pi over 6 is here. 0 is here. Negative pi over 6 is here. Negative pi over 3 is here. Now pi over 2, negative pi over 2 would be here. I didn't make the axis quite long enough, but pretty close. So those would be my 5 values. And you can see they're spaced out every one, so I can keep the pattern going eventually. Now there's no vertical shift, but the amplitude is 1.5. So I'll just go up 1.5. That'll be my top. My midline is just 0 because it doesn't go up or down, and this is going to be the bottom. Now, this is cosine, so cosine is going to start at the top. So we will start up here, and then to the middle. Up, it's flipped, so I'm wrong. We have to start at the bottom. And to the middle, to the top, to the middle, to the bottom. So it looks something like this. Now this is a fine graph, and this would be 100% correct. If I wanted to continue, I can see the pattern is just going to be every unit of this values as I go through it. So we would go here to here to here to here to here to here. If I wanted to get more of the graph, you certainly don't have to do this, but if you wanted to, that was pretty terrible, you're welcome to do so. So let's look at another one. Now this one is by far a much easier problem, and I'll tell you why I would say that. So if you look inside, we have 3 sine 1/3 x. Well, there's nothing to factor out because there's nothing added or subtracted inside. So right away, I know there is no phase shift. When there's no phase shift, this becomes pretty simple. Okay? It's very similar to the first stuff we did. So the amplitude is going to be 3, same thing, it's the absolute value of the thing in front. Now the period is going to be 2 pi divided by 1/3, because that's the number in front. So we'll have to keep change flip, so this is 2 pi times 3 over 1, which is 6 pi. And there is a vertical shift in this case, it is 1. We're going to go up 1. No phase shift because nothing is added or subtracted inside the value. Okay, so now we'll get our point. So again, we'll do the same thing. Now, we'll change the period still like we did before, but we will not have to do a phase shift, so that'll make life easier. So we'll start with 0 and pi over 2 and pi and 3 pi over 2 and 2 pi. So if you change it, we're going to divide all these by 1/3, because that's the number in front when I'm changing the period. But remember, we said dividing by 1/3 was the same as multiplying by 3, which will be an easy way to go. So 0 times 3 is 0. Half times 3, we'll just put it on top, so 3 pi over 2. Pi times 3 is 3 pi. 3 pi over 2 times 3 is 9 pi over 2. And then 2 pi times 3 is 6 pi. There's the 6 pi I got earlier, so everything works out. So if I look at my grid, I should be able to segment that. There's 0, there's 3 pi over 2, there's 3 pi, there's 9 pi over 2, and there's 6 pi. So in this case, the shift up is 1. So I'm going to make my midline at 1. So I'll kind of put the dashed line there. Our amplitude was, I forgot already, it was 3. So I'm going to go up 3. So up 3 from 1 is at 4. And down 3 from 1 is at -2. And it's sine, so I'll start in the middle, which is the midline. So I'll start there. It's not flipped, so then it'll go up, down to the midline, to the minimum, back to the midline. So not much room to do much else on this one because this is a very large period of it. So something like that. Okay? So resegment your axis, figure out your shift up and down, get your top and bottom line, and then just if it's sine, it starts in the middle. It's cosine, it starts at the maximum, unless it's flipped. Then it would start at the minimum, and sine would go down. Okay, so question 3 says, where does the function f of x equal cotangent have vertical asymptotes? Okay, now we have these formulas in class, but if you don't want to think about that, I totally get it. If you think of the unit circle, which I'm just going to draw really quickly here, 1, 0, -1, 0, 0, -1, and 0, +1. So cotangent on these, so tangent, if you recall, we remember tangent. Tangent was y over x. So cotangent was x over y. So the asymptotes are going to occur with wherever the bottom is 0. So they're going to occur everywhere where y is 0. So that's going to be at the 0 and at the pi. Now, if it was a different function, it would be at the other ones, at the pi over 2 and the 3 pi over 2, like we talked about in class. So this one's going to happen at all increments of a pi, 0, 1 pi, 2 pi, 3 pi. So we'll say k pi, where k is an integer. But remember, just like we said earlier, there's not just an x in here, there's a 2x. So we'll say 2x equals k pi, where k is an integer, and this is how we'll find our asymptotes. So if 2x equals k pi, we will have to divide by 2. So x is going to equal k pi over 2, where k is an integer. So if you start putting values for 0 here, you can list a bunch of asymptotes. So if I put 0 in there, 0 times pi over 2 is pi over 2. If I put a 0 is 0. Put a 1, it's pi over 2. If I put a 2, it's 2 pi over 2, which is pi. 3 pi over 2. 4 pi over 2, which is 2 pi. 5 pi over 2. I could go backwards and say negative pi over 2, negative 3 pi over 2. These are all asymptotes of this function. Again, use the unit circle to set your thing up and then just divide or multiply to find your asymptotes. Okay. So question 4 and the rest of this goes back to what we talked about before with law of sine and cosine. On the test, you are provided with the law of sine and cosine, so it is not something you have to memorize. I just put it on there as the generic, sine A over A, sine B over B, sine C over C, and then the A squared equals B squared plus C squared minus 2BC cosine of A. So those will be given to you, and you will just have to plug in your numbers, maybe change the letters, like this one is D, E, F, but try to go from there. So if we recall, law of sine is when you have some information, law of cosine is when you have others. So just to review, law of sine, and this is not given to you, is when you have 2 sides in the non-included angle, or if you have 2 angles in the side in between. Cosine is when you have all 3 sides or 2 sides in the angle in between. So to figure out which of these we're going to do, we'll have to draw our triangle. So in this case, it is D, E, F. So I know little d, which is across, is 92 inches. Little e is 70 inches. And we know little f is 65 inches. Okay? So this is obviously side, 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 because I have all the sides. And I'm trying to find angle D. So this is probably one of the harder ones. Now, the only one that has the 2 solutions possible is up here, so this is not that case at least. So since I'm trying to find D, my law of cosines, I'll start with little d. So little d squared plus e squared plus f squared minus 2ef cosine of capital D. Now a lot of this will just be plugging in numbers. Little d is 92. Little e is 70. Little f is 65. Minus 2 times 70 times 65 cosine of angle D. So this is not one you can put in your calculator all at once. This is the one where I'd figure out what this is. I'll figure out what these 2 are, and then I'll figure out what these 3 multiplied are individually. Okay? So 92 squared is 8,464. 70 squared plus 65 squared is going to be 9,125. 2 times 70 times 65 is going to be 9,100. Cosine D. It's 9,100 cosine D. I'll just solve. So I'll subtract 9,125 from both sides. So 8464 minus 9125 is negative 661 equals negative 9100 cosine D. So then I'll divide, so cosine D is going to be 661 over 9100. So now I just got to get rid of the cosine, so I'll take the inverse. So inverse cosine of 661 over 9100. So if you believe my calculator, which is set in degrees, I got 85.8. It wants it to the nearest degree, so it would be 86 degrees. So this is a classic side problem where you're given all the sides, you plug into the law of cosine, you do a little algebra, and you find your angle. Okay, let's look at question 5. Question 5 says triangle DEF, and we have some other things. We want to figure out nearest tenth of an inch. Okay. So again, we got to figure out if it's sine or cosine, what's going on. Let's see what we get. So I'll draw the triangle again. So we have DEF. So little f is 960 inches. Angle D is 101 degrees, so it's definitely not to scale. And then E is 27. So right away I know this is law of sine, because anytime you're given two angles, law of sine. Now, like we did earlier, if you have two angles, it's just to your benefit to find the other one. So if I just do 180 minus the two existing angles, I can find the other one really quickly. And that'll be helpful when we do this law of sine problem. So with these variables, remember sine of capital D over little d equals sine of capital E, which is the angle, over little e, sine of angle F over little f. Now we are trying to find little e, that's our goal in this problem, and we have side F. We don't really have side D either. So if I start plugging things in, sine of D, I do know angle D, it's 101 over D, which I don't know. Sine of angle E is 27 over little e, which I do want to know. And sine of F is sine of 52 over 960. So I want to find E. I have this. I really don't care about D. I'm not trying to find it. So I'm just going to use those two ratios. So sine 27 over E equals sine 52 over 960. So I would just cross multiply and solve. So I would get E sine 52 equals 960 sine 27. And then I will just simply divide. So I get 960 sine of 27 over sine of 52. So again, make sure you're in degrees. Literally just we're going to plug it in the calculator and see what we get. So 960 sine of 27 divided by sine of 52. I got 553. We're going to nearest tenth of an inch, so 553.1 inch. So that is side E. If I felt like it, I could find side D. I'd just use a different ratio. And I found all the angles already, which is kind of pretty easy because I was given two of them. Okay, let's look at the last one. We have another triangle. We have triangle PQR, and we're trying to find values of angle Q. So we'll do the same thing. So PQR, so here's P, here's Q, here's R. So we have little q, which is 420 inches. We have little p, which is 400 inches. And we have angle P, which is 64 inches. Okay? So we have a side, and an angle. So the angle is not between these two. So since it's not between these two, we're going to have to use the law of sines. But unfortunately, it's the law of sines where you could have a second solution. So this is the sine of P over P equals sine of Q over Q equals sine of R over R. I can tell you already, I don't know angle R and I don't know side R, so I'm definitely not going to use this one. So I'm just going to use the other two. So sine of angle P, which is 64, over little p, which is 400, equals sine of Q, which we don't know, over little q, which is 420. So we got to solve for sine Q. So I would multiply by 420. So sine Q equals 420 sine 64 over 400. And then I would, again, just like the previous problem on the previous page, I took the inverse cosine. Here I'll take the inverse sine. So inverse sine of all this stuff up above will give me an angle. Now the problem with law of sine is you can have no solution, you can have two solutions. So let's see what we get. So inverse sine of 420 sine 64, I'm just typing this legitimately in a calculator. It gives me 70 point, where we're going nearest degree, so 70.6, so 71. So the question is, would 71 fit in here for r with 64? It absolutely would, so this is definitely a solution. Now what we have to do now, though, is we have to say, okay, there is a second possible solution. We'll call it Q1. So we have to take 180 minus 71, which in this case is 109. So now my question, would 109 fit in here? Well, 109 and 64 is still less than 180, so this is another valid answer. So only for law of sines, when you're finding the angle, do you have to check for the second solution. If it fits in the triangle, they both work. If it doesn't, it doesn't. So this is your first review. We'll review again before the test in class, and then we will take our test and move on.